Hello everyone, this is Siddiqur Rahman and welcome to the continuation of the fifth lecture of the second week. So let's begin. By the end of this lecture, you guys will be able to convert the decimal number into the binary number. So let's move into the next slide. This slide represents the overall scenario of this lecture, such as conversion of decimal to binary, methods of decimal to binary conversion, steps of decimal to binary conversion, general knowledge, example of concept, example of fractional type problem, example of mixed type problem, and some homework for your practice. So let's move into the next slide. From this slide, we may learn the methods of the conversion of decimal to binary number. So let's start. The most popular way to convert a decimal number into the binary is the double-double method. In this method, the given decimal number is progressively divided by 2 and writing the remainder after each division. When all the remainder is read in reverse order, the binary number is obtained. So let's move into the next slide. From this slide, we may learn how to convert the decimal number into the equivalent binary number. So let's start with the step number 1. Divide the decimal number which is to be converted by 2, which is the base of the binary number. Next step, the remainder which is obtained from step number 1 is the least significant bit of the new binary number. Next step, divide the quotient which is obtained from the step number 2 and the remainder obtained from this is the second least significant bit of the binary number. Next step, repeat the process until the quotient remains 0, and the step number 4 is carefully remembered for mathematical problems. Last step, the last remainder obtained from the division is the most significant bit of the binary number. Hence, arrange the number from most significant bit to the least significant bit, that is from bottom to top. So let's move into the next slide. Well, this slide represents a general overview of the division and its parts. We already habituated or we already familiarized of this symbol. In the left, in division, in the left side, which is called divisor, and in the middle part, which is called dividend, which is only divisible by divisor, and in the right side we found quotient, and in the bottom side, or you can say in the bottom part, we can get the remainder if dividend is not divisible by the divisor. Well, so let's move into the next slide. This slide represents the conceptual example of the conversion of the decimal number into the binary number. So let's start with the question. Consider the conversion of the decimal number 25 into its equivalent binary number. We already studied in this lecture that how to convert decimal number into the equivalent binary number. So let's begin. In here, or in this problem, the decimal number is 25. So we need to divide first the base number of the binary, since we would like to convert the given decimal number into the binary number. So let's start. 25 is divided by 2, then we get in the quotient part is 12 and a remainder is 1, which is symbolized the first remainder. Okay, next, then 12 is again divided by 2, we get in the quotient part is 6 and a remainder is 0, which is symbolized by second remainder. Then Again we divide 6 divided by 2, and we get in the question part is 3 and 0 in the remainder section, which is symbolized by third remainder. And a question may arise in your mind, how long we divide? So it's totally simple, or you already know in this issue that we need to divide until the quotient part is 0. So next we divide 3 divided by 2, um, and we get in the question part is 1 and the remainder is also 1, and which is symbolized by fourth remainder. Well, and the last portion, and 1 is also divided by 2, and in this situation we don't get any quotient because 1 is smaller than 2, and 1 is remainder, and which is symbolized by the fifth remainder, and we are already get our equivalent binary number. And if you see in this problem, the arrow sign is headed from bottom to up, and it represents that we need to read the equivalent number is from the bottom to the top. So let's see what is our calculated equivalent binary number, which is 11001. Okay, so let's move into the next slide. From this slide we may learn another example like the previous one, but this time we learn different example from the previous one. So let's start with the question, what is 0.35 decimal number in the binary number? Okay, or what is the equivalent binary number of the given decimal number? Okay, and this number is a fractional type, so this problem is also fractional type problem. So let's start with the solution. First we need to multiply the given decimal number by 2, so we get 0.70, and if you see there is no carry, that's why in this row a line you may see or you may notice which is with a carry of 0. In next row, when we multiply 0.70 by 2, then we get 1.40 of the product value, but we write 0.40 and 1 is the carry value, that's why with a carry of 1. Next 0.40 into 2, then we get 0.80, and there is, and in this step or in this row there is no carry founded. So let's move into the next step. 0.80 into 2, then we get 0.60. Actually we get 1.60, but in here we write 0.60 and 1 is the carry value, that's why in this row we write with a carry of 1. Next 0.60 into 2, 0.60 into 2, then we get 0.20. Actually we get the value of 1.20, but we write 0.20 and 1 is the carry value. That's it for the solution. And if you see in here the right column, the arrow head is top to bottom, is starting from arrowhead is indicating from top to bottom, so that's why we read it 01011. But before that there is a indication in the question 0.35 decimal number, so we already mentioned a arrow sign in which symbolized by binary point, and point in question the point is represent the binary point, that's why we placed the point from the first number of the table, from the above number of the table, that's why we placed the point before 0. So that's why we write in here the equivalent binary number is 0.01011, and the equivalent binary number of the given decimal number is 0.1011. I hope you understand this solution of the given problem. So let's move into the next slide. From this slide, you may learn another example of the conversion, and you may see in the question that this problem is different from the previous two. Uh, what I meant that this type of problem is named as a mixed type problem. And let's start with the question. What is 13.40 decimal number in the binary number? Well, so if you see in this question, then you may find two part of this question. One is 13 and another one is 40, and we already done two problems separately. One is only 25, which is non-fractional problem, and another one is 0.35, which is a fractional problem. And if we understand the previous two problem, then we have no problem to do this problem. So I hope if you gone through this problem, you will understand very well. So let's move into the next slide. And for your practice, I attached some examples in this slide, and I hope you will do by your own. So let's move into the next slide. In the next lecture, we would like to learn binary to octal conversion. Next. That's all for this lecture, and thank you guys for your attention, and see you guys in the next lecture. Thank you.